Find the derivative of g of x equals 3x squared minus 4x plus 8 all over x cubed, then evaluate g prime of 2. G of x is made up of the quotient of two functions. Quotient means division. 3x squared minus 4x plus 8 all over and divided by x cubed. One option is the quotient rule, but if you can physically take the quotient because you have a single denominator, which is what we have here, you can find the derivative in a quicker and simpler form. We can put each of those numerator terms over that single denominator. We can break it up into its own set of fractions. 3x squared over x cubed minus 4x over x cubed plus 8 over x cubed. Each of those terms are added or subtracted and can be done individually for the derivative. The first two terms, we can cancel some of the x's out. The first term, there's an x squared, 2 x's in the numerator, and an x cubed, or 3 x's in the denominator. We can cancel the 2 from the numerator with 2 of the 3, leaving us with an x in the denominator there. 3 minus 2 is 1, and that's why we get x to the 1. You're subtracting the exponents there. The second term, we can cancel the 1 x in the numerator with one of them in the denominator, leaving us with an x squared. So that will give us a 3 over x minus a 4 over x squared plus an 8 over x cubed. Now each of these have a number in the numerator and an x in the denominator, which means we can rewrite them with a negative exponent. The first one can be rewritten as 3, move the x to the numerator and call it x to the negative 1. Second will be minus 4, move x to the numerator and call it x to the negative 2. And the third, plus 8, move x to the numerator and call it x to the negative 3. And by doing that, each of those terms are a power rule, and that avoided the use of the quotient rule for the original quotient. G prime of x will be, the first term's a power rule, bring down the minus 1, multiply it with the 3, minus 3, x raised to the minus 1 more, which is minus 2. Second term, minus 4 times a minus 2 is a positive 8. X raised to the minus 2 minus 1 more, which will give us minus 3. And then the third term, 8 times the negative 3 is negative 24. X raised to the minus 3 minus 1 more will become minus 4. Now all those x's raised to negative exponents just mean to move them to the other position. They're in the numerator. Let's move them to the denominator and call them a positive exponent. So the first term, do not move the negative 3. That is not raised to a negative exponent. Negative 3 over x squared. Do not move the 8, just the x, plus 8 over x cubed. Do not move the negative 24, just the x. Negative 24 over x to the 4th. There's our derivative. It's always possible to get a common denominator between those and put it over a denominator, but it can also be left like that. The next step is to evaluate g prime of 2. That means to plug a 2 into each of the x's. So negative 3 over 2 squared plus 8 over 2 cubed minus 24 over 2 to the 4th. That will give us a negative 3 over 2 squared is a 4, plus 8 over 2 times 2, 4 times 1 more 2 is an 8, and then minus a 24 over 2 times 2 is 4, times another 2 is an 8, times 1 more 2 is a 16, so 2 to the 4th is a 16. Now we'll be able to simplify these fractions. Before we get a common denominator, we're going to need to combine all of them together. The middle one, for example, 8 over 8, those can cancel to give us a 1. And it turns out the third fraction is also divisible by 8 in the numerator and denominator. Divide the 24 by an 8 and you'll end up with a 3, and the 16 by an 8 and you'll end up with a 2. So this will give us a negative 3 over 4 plus 1 minus 3 over 2. Looks like the common denominator is going to be a 4. So we're not going to do anything with the negative 3 over 4. We will multiply the 1 by a 4 over 4, and the minus 3 over 2 by a 2 over 2, so that their denominators all become 4. So we have a negative 3 over 4 plus a 4 over 4, and then minus 3 times 2 is a negative 6 over 2 times 2, which is a 4, negative 6 over 4. Minus 3, let's add the numerators, plus 4, that's a 1, and then minus a 6, that's a negative 5, and all of that goes over that common denominator. And so I'm ending up with negative 5 over 4.